Hi everyone, welcome to Math. Today we are going to study chapter 6 Triangles, Theorem 6.2. This theorem is actually converse of basic proportionality theorem or Thal's theorem. Just converse of it means just opposite of it. So what actually the basic proportionality theorem says? It says that if there is a triangle and for this triangle, one side of the triangle when we draw a parallel line, then that parallel line will divide these two sides of the triangle into equal ratios. That's what we have studied in the BPT theorem. But here just opposite we have to prove. Here what we have to prove is that if in the triangle, if two sides are ratios are equal, if these two side ratios are equal, then these two lines are parallel. That's what we have to prove. You see, the converse of BPT theorem says that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So that's what we have to prove. So in BPT theorem, it will be given to us DE is parallel to BC. DE is parallel to BC. What we have to prove is AD upon DB is equal to AE upon EC. Okay, so this will be given in BPT theorem. This is given, we have to prove this. But here in this theorem, this is given to us, we have to prove this. Means the ratios are equal. So we have to prove that two lines are parallel. Okay, so once again read this. If a line divides any two sides of the triangle, if a line is dividing any two sides of the triangle in the same ratio, then the line is parallel. Then the line is parallel to the third side, because this is dividing two sides into equal ratio. So that line will be parallel to the third side. So that's what we have to prove, just the opposite of BPT theorem, converse of it. Okay, so now here what is given to us, already I told you what is given to us is these two sides, the ratios are equal. That is given to us. So AD upon DB is equal to AE upon EC. So this is given to us in theorem. Okay, what we have to prove is, we have to prove that this line are parallel to this line. That's what we have to prove. So here we have to do a construction, that is we assume that, first we assume that this is not parallel. Therefore parallel to BC we are drawing another line E dash. Okay, so we assume that this is not parallel, so this is parallel. Okay, so we construct DE dash parallel to BC. Okay, this we are constructing parallel to BC. You can write also, we assume that DE is not parallel to BC. Okay, now we have to prove. What we have to prove now? That DE is parallel to BC. That's what we have to prove. So let's begin now. First of all, let us write down the ratio, that is AD upon DB. AD upon DB is equal to AE dash upon E dash C. Okay, this is by construction, because we have constructed this E dash, so AE dash and E dash C construction. Okay, so equation 1. Now let's write AD upon DB. AD upon DB is equal to AE upon EC. This is how, by basic proportionality theorem. Actually what is given to us, actually it is what given to us, no? AD upon DB and AE upon EC, no? That's what given to us. So you can write by basic proportionality theorem, or you can write also given to us. Okay, so we take it as equation 2. So now from equation 1 and from equation 2, you see left side is the same, that means right side also should be same. So you can write down that from equation 1 and 2 we have, if this side is equal means this also will be equal. So AE dash upon E dash C will be equal to AE upon EC. Okay, these are equal. If these are equal, now let us add with this 1, adding 1. Why we are adding that I'll tell you. Adding 1 on both sides. So we'll add 1 on both the sides. That is AE dash upon E dash C plus 1. Same way here also AE upon EC plus 1. So when there is 1, let's take here denominator we have this, but here denominator nothing is there, so we consider there is 1. Here also in denominator there is nothing else is there, so we consider 1. So we have to take LCM. Okay, LCM we have to take. So when we take LCM, both the side, here also in denominator we have to get this, here also in denominator we have to get this. So what we will do, with E dash C we will multiply both the side. Then what we will get with both the side, when we multiply, this will get in numerator also, it will come in the denominator also. Same way with EC, multiply both the side. So here also we will get EC, here also we will get EC. Okay, so AE dash then plus E dash C, both side will be EC, so let's write common. So same way here also AE plus both side will be EC, then EC. Okay, so now look at this, AE dash plus E dash C is what actually? AE dash plus E dash C is what? It is actually AC only. So can we write here instead of this AC? Then this you write as it is. Okay, here also AE plus EC, what it is? AE plus EC is what? Actually AC only. So I'll write AC. So that's why we added. Now you understand why we added 1 here? Because to get this step. So now both the side AC is there, let's cancel. So then what we will have? 1 upon E dash C. Here also 1 upon EC. So cross multiply. So when we do the cross multiplication with EC, EC into 1 will give us EC, and E dash C into 1 will give us E dash C. So we have proved that EC is equal to E dash C. We are proving EC is equal to E dash C. That means if EC is 5 centimeter means E dash C also is 5 centimeter. If the length is the same, that means can we say that E dash and E is the same point, it is coinciding. So you can write like this. From the above, we conclude that E dash and E coincide with each other. So if they are coinciding each other, that means if DE dash is parallel to BC means DE also has to be parallel to BC. Thus, we can say, because we have assumed here, right, DE dash is parallel to BC. If we can see, then can we say DE is parallel to BC? So thus, if DE dash is parallel to BC, then DE is parallel to BC. Hence, proved. Okay. So if we consider this is parallel to this, then both the points are coinciding. That means DE should be parallel to BC. So we have proved this point. So I hope it is clear to you. Thank you. God bless you.